Hello everybody, Jean here with the restoration video looking at some 80s tech, specifically this Commodore VIC-20 and some modifications I did to it. I learned to program on this specific VIC-20 in the early 80s and it's been in storage since about 1985 until about a week ago when my father was kind enough to give it to me. So I was looking forward to the Powerup and hopefully no serious problems. And I connected it to my plasma screen via the composite video, and the audio I connected to my amp. Also, this is a special cable that I made up. I opted not to use the RF modulator because that's just another item in the chain that reduces video quality. So this is the pinout on the VIC-20. You use pin 2 for both cable grounds, and I opted to use pin 5, which is video high, for the composite, and then pin 3 for the audio. We'll have a look at pin 4 a little later on as well. That there looks like it could be a lower impedance or maybe a lower signal level, so I opted to go for the higher video output. And this is the image I got when I switched on the VIC-20. A little bit concerning, so I referenced some research online, and some of the guys suggested pulling all the socketed chips and reseating them. That's what I did. I also looked at the circuit diagram, specifically of the video display chip, and 2 trimmers that I could potentially adjust to try and rectify this problem. The 2 trimmers are located right there, and they adjust the luminance and contrast. This is also a trimmer that adjusts the clock frequency, so I suggest rather not to do any adjustments to that if you don't need to. As you can also see, the electrolytic caps still look very good. No leakage on the board. We'll take a closer look at that just now. So this is during the alignment of those 2 pots. Eventually I got the image to stabilize, became black and white, and then a bit more adjusting until the color appeared, which was a huge relief. And also they suggest you switch off the VIC-20 and power it back on to make sure the display chip synchronizes, so no problems with that. Pretty awesome. So let's have a look at the audio. I ran a test program just to test the audio. This comes straight from the VIC-20 manual. And no problems with the audio. I think they call this UFO landing. So on the to-do list, let's go through this is the VIC-20 that I last saw in the 80s. Still has its joystick, power supply, RF modulator and cassette deck. Everything's still in perfect working order. And there's the one modification that I thought I'd do. I mounted a small little fan in the lid close to the video display chip, which gets really hot. This little fan is about 38 by 38 by 10 millimeters, so it's very small. I didn't want to go for a really huge modification, so I opted to go for a smaller fan. And also the RF shield I cut slots above all the chips just to assist with ventilation of air through the system. There's a little 5-volt power supply built for the fan. I'll show you a bit later. The fan draws quite a bit of current, so I didn't want to put an extra load on the VIC-20 power supply. So let's have a closer look at the inside and also the shell. This is after I cleaned the case. Next to it you can also see the ZX80 Sinclair that I also played with when I was a young boy. You can see from my hair that I'm quite grey now. So yeah, it still has the RAM expansion, and it's in very, very good condition as well. Thanks to my father who looked after these two computers so well. Also wiped down that one with a wet cloth just to get rid of the layer of dust. There's the joystick, also just wiped off the dust. Everything was stored away in plastic wrapping, and there's the little RF modulator. I tested that, it also still works. But as I say, I opted to go for the AV composite video and audio. And there's the case, still very white, wasn't exposed to much UV, so I could probably clean it up to be its bright white self. This one was made in Germany. It's got a slight yellow tint to it, but otherwise it's in pretty good nick. So let's have a look inside. Pretty easy to open, just remove the 3 screws in front. There's a little nick in the bottom, which I'll leave. I'm not going to worry about that. The keyboard as well, I just wiped clean with a cloth, and a little screwdriver to get in between the keys. I remove the keyboard connector, move away the RF shield, and take a look at the PCB. Power supply gets really warm as well. I think in the Commodore 64 that is mounted in the external box. The RF shield is like a cardboard with some tin foil on one side. Those are the chips that get really warm. What I was going to do was look at better airflow through the system. And there's the little fan, really miniature, 38 by 38 by 10 mils if I recall correctly. And I opted to mount it as close to the video chip as possible, because I don't want that chip to blow. Apparently it's very, very scarce. So I opted to mount the fan there. The other alternative was on the right near the power supply. That's just a close-up look at the video chip. Unfortunately my camera doesn't do close-up zooms very well, but you get the idea. There are those 2 trimmer pots to adjust the video signal. Over to the controller chips, which I suspect after I reseated those that the keyboard started being responsive again. There's the processor, kernel and DOS, basic, and all these larger chips get really hot, as well as the power supply. The large electrolytic still tests fine, it didn't start leaking, so very, very lucky about that. And here's the keyboard, also very good condition. There's the caps lock switch. So let's have a look at the lid, air vent and fan. I used the bearing chart to get the proper angles for the little holes I wanted to drill. I just cut out a template that I would use on the lid itself. I didn't have to battle with the compass and a protractor. There we have a little piece cut out with all the angles for the holes. There I measured from the center of the fan to the center of the blades, and we marked those off on each of those lines. I later found a little container that has the right diameter, so I drew a nice circle around that center, which helped a lot as well. But just verifying the position. Just sticking it on with masking tape. It can be easily moved and removed later. I'm just checking the distance from the DIN connectors, and from the one side, that's how far in I wanted to mount it. Just needed to move that over slightly, just above the RS-232 connector there. It's a nice thing about masking tape. Pardon the grey hair. I don't know where that came from. The last time I played with this Vic, I had brown hair. Alrighty, so there it is in the position I wanted. Just verifying, measure twice, drill once. This is also quite brave of me to have taken this step to modify this Vic. Many people say it will reduce its value, but I'd rather have a working Vic than a Vic that overheats with capacitors and chips blowing. So that little fan would just assist to get some airflow through the computer that there wasn't before. So I'm just checking center of the fan to the center of the air blades. I didn't want to make a hole bigger than the little fan itself. So the proof of concept to check whether the fan moves any substantial amount of air through the system. This was after I drilled the little holes. I used the punch to mark out the position, and then I used I think it was a 3mm drill to drill out the little holes, and I mounted the fan permanently just to test it. It's just next to these two bracing pillars inside the lid. I connected it up to a little power supply I have just to check that the fan works, and it draws quite a bit of current, and it has a nice airflow as well. It's not too loud, There's a close-up, 5 volts, drawing about 200 milliamperes, which is quite a bit of current that I didn't want to subject the VIC-20 power supply to. There you can see 200 milliamperes. It's quite a lot. This is really up close to the fan. It's a little bit noisy, but from a normal seating position you can hardly hear it. It's like ambient noise in the background. So let's have a look at the 5 volt supply for the fan. Pardon the noise in the background, that's a larger fan that I had on. It was a really warm day here in South Africa. So that's where I opted to mount it, close to the power connector and close to the fuse and filter. I extended the lines of the fan and heat shrink those joins. So there's the little voltage regulator, 7805, bridge rectifier and 1000 microfarad 16 volt cap, and we're getting 5.06 volts, a nice steady voltage. And yes, that regulator gets warm, so I opted to put a little a little heat shield on it. So let's have a look at the RF shield air vents. As I say, it's a cardboard cover with this sort of aluminium foil stuck to the one side. So yeah, I'm just marking off where the main chips are that get warm. Just with some masking tape again. And try not to press the masking tape down too hard, because when you peel it off, it could lift the foil. That's what happened in my case. But no major harm done. So now I'm just going to mark off with a pen where the chips are located exactly, so that I can cut the little slots for the vent. To remove that shield, just take out the PC board with a couple of screws. So there it is, just lifts out. We've got shielding underneath the board as well. So that's after I cut the slots with a little PC knife. Also opted to cut holes on the front side, because otherwise that cover effectively blocks any airflow through the system. You can see that row of larger rectangles are cut into the front side, and then these slots above each chip, and I used the same measurements as the air vents in the bottom lid. So there's the little fan mounted after I cut the hole with the adjustable drill, and there's the 5-pin DIN, the 2 RCA connectors. This was actually a 7-pin DIN, and I cut off 2 of the unnecessary pins. Apparently those connectors are quite scarce. So you can see some of the foil came off when I removed the masking tape, but that's no hassle. There's a close-up of the little 5 volt power supply with a heatsink on it. So just to review, first we mounted the fan. I drilled out a circular hole with some 3mm and 2mm drills to test the concept, and it worked. Then I took an adjustable drill to drill out a nice, neat, larger hole. Mounted it very close to the display chip. Cut in the slots, which has made quite a bit of a difference, by the way. And also I tested the fan with a piece of tissue paper, and from about 2 centimeters it starts sucking the tissue paper closer, so it's quite effective, and it blows quite a bit of volume, or sucks quite a bit of volume through the computer. There's a close-up of the 5-volt supply. I might have to put a larger heatsink on that 7805 voltage regulator. So it powers up the fan quite nicely. And into the future, what am I going to be doing? I might create some games perhaps. For those of you that have watched one of my older videos, I wrote this little game called Missile Command in PC Basic, which is very similar to the game that I played on the VIC-20. Little did I know that my father would be giving me the VIC-20 just after this. So what I'm going to do is port the game over to Commodore Basic, but there are some difficulties to that. I'm going to have to use poke and peek statements instead of locate. I use locate in the PC Basic version quite a lot to locate the position at which I want to print whichever character I need. And in Commodore Basic, they don't have a locate statement, so here's a link to the video that I did for this Missile Command game in PC Basic. I'll include the link below. From the VIC-20 manual, you can read about the screen memory maps, specifically for the character codes. You'll note that there's only about half the columns and rows that you have in IBM, so using BASIC there. Here we've only got 22 columns by about 22 or 23 rows, whereas with PC Basic or IBM Basic we had something like 80 columns and about 23 rows. So the color codes are also mapped out in memory, so instead of using the locate command, I'll be using the poke, which prints the characters directly to the memory map, which is also a more efficient way. So here's a little program I wrote that demonstrates what I'll need to do using the poke command or statement. And very similar, I'm also using a little greater than or equal to or less than sign. From the game, you'll recognize that character. So I'm just going to have to adapt the game I wrote in PC Basic to work on the VIC-20, but I should be able to do it. So hopefully I'll be doing that in the near future. That is definitely on my to-do list. So I hope you found this interesting and useful. Hopefully in some way it inspires you to get the old VIC-20 out of the cupboard, or to buy one off eBay, and to start playing games on it again. Start writing programs, modifying the VIC to work a little better. Not that there was anything wrong with the original, but technologies improved in leaps and bounds over the last decade. So there are many other channels on YouTube that look at restoring the old computers, the VIC-20, C64, PET, all the old computers from the 80s and early 90s. So check that out. Very interesting. As I say, thanks for watching. I'll be getting back to my Mars anomalies directly after this. Hopefully I'll find some for you soon, which I'll be presenting on the channel. Thanks for watching. I'll be back soon. Bye bye for now.